Well, here we are. We're going to look at this facility for blending and bagging grain. We're going to roll it around a little bit. We have, for start, we have a receiving conveyor here. Trucks are going to drive across. It is above grade. So if we get this right at grade, it is right above grade. Comes up here. We're going to look at the measurements for that right away. This is the conveyor. We have 20 foot 5 inches from the center of the hopper to the elbow. We have 28 foot 9 inches, 8 inches, somewhere in that range, from the center of the hopper to the center of the drop. We have 7 foot 3.5 inches of rise from the bottom to here. And these measurements, if all of these measurements are within a couple inches the same, that's great. We're not looking for exact, we're looking for very close. So I forgot to put one measurement on here that you're gonna need to have. So we're gonna put that on here right now. And that is the hopper size. That's a 10 foot hopper. So that tells you everything you need to know for designing that drag conveyor. Now it is spec'd out as a 3100 Lambton receiving drag, Lambton conveyor. The elevators, well, we're going to look at the tower next. We have drawn in here a 60 foot high 8x8 support tower. That is to hold a little, if you see in here, there's a little elevator and a larger elevator. I changed the view to try to get it to make it so it's easy for you to see everything. But inside there, we have this little elevator and we have this bigger elevator. The larger elevator is a Lambton 65 foot discharge with a 6-hole distributor, 8-inch distributor, electric distributor. So this receiving drag goes into that large elevator. That large elevator has 4 spouts. One to this hopper bin, one to this hopper bin, one to this hopper bin. Then it also has a drop spout here to this other spout. This is a spout that I need both elevators to be able to go to bagging. That way, if we're not roasting and we're receiving, we can bag through there. Or if we are roasting, we can bag through the big elevator. They're all, so if you look here, we have a little different colors spouts. These 3 spouts are 8-inch spouts, and these 2 here are 6-inch spouts. So they're blue. So if we go on here, so these here are blue spouts. So we have 2 6-inch spouts off the blending elevator, one to bean bin at 21 foot, and one to the bagging system at 60 foot. And then there's a 12 footer that drops between the big elevator down to that little spout. So that elevator, that larger elevator, the receiving elevator, is drawn in at 65 foot discharge height. And this bin here is a raw bean bin. So coming off the bottom of there, we have a 24 foot auger coming in to feed the back of this roaster. That has 2/3 pitch on the first 30 inches. It has a 3 horsepower motor on the auger. and it's 24 foot long. It has it explained here. It also has to turn 180 RPMs. So we will probably need a gearbox on there because we want 180 RPMs. Here we have this auger here going out, dumping into this small elevator. This is, again, is a 6-inch auger. This one's 30 foot long. It has 2/3 pitch on the end tail of it. And this also needs to turn 180 RPMs. You're going to notice a trend in this system where lots of parts are identical. Every auger in this facility gets run 180 RPMs with a 3 horsepower motor. Yes, this is a 30-foot auger. This is a 24-foot auger, and the others are going to be 12-foot augers. But they all get 3 horsepower motors and turn 180 RPMs, and 180 RPMs, 3 horsepower motors, and have 2/3 pitch flight on the tail. So here, that there goes up. That would be the auger going to the roasting. Then we have our 12-foot augers. I believe they're 3 of those augers. They're 12 foot by 6 inch with 2/3 pitch on the first 30 inches of the tail where they take in. They turn 180 RPM, and they turn 180 RPM, and they have 3 horsepower motors. They feed this round bottom conveyor, this Lambton round bottom conveyor, complete clean out. This is our blending setup. So that conveyor is going to have a K valve in here. I don't have it drawn in there, but a K valve so that can go to either or elevator. It'll be a manual K valve with a sensor on it to verify the position it's in. That conveyor right there, we're going to look over here and we're going to look at the specs of that conveyor. There the specs are of that conveyor. It's a 26-foot long conveyor. It has about 8 foot of rise. That way we have enough height to have the K valve and dump into the elevators. We have a little over 24 foot horizontal overall length, but it's a 26-foot conveyor with 8 foot of rise. So we're going to go back over here. We covered the 2 elevators, the 6-inch spouts. This big elevator has a 6-hole electric Lambton distributor and a 8-inch. It's an 8-inch 6-hole electric Lambton distributor. It has 3 spouts, one at 34 foot, one at 29 foot. This is 34, I think, 29, and 36, if I'm not mistaken. Either or, it don't really matter. And then receiving conveyors spec'd at 3,100 bushel an hour, 3,100 Lambton, or 3,000. Feeding a 3,100 elevator, 8-inch spouts. These are our receiving elevator info, 65-foot discharge height. Roasting blending elevators, a 900 bushel per hour Lambton elevator with electric 2-way valve. 1 spout to bagger and the other spout to roasted bean bin. And if we look here, that elevator is a little bit smaller. That's going to have a 55-foot discharge height. Right about a 55-foot discharge height. 50 foot would be fine. Somewhere between 50-foot discharge height would work fine on there. I have it drawn at like 52 foot. So, see that I have it drawn at like 52 foot there. We'll measure it here just to make sure I got my... Yeah, it's drawn at 52 foot discharge, which is a good height. That's plenty big enough for everything it needs to do if you want to go right on that. And then that is going to be complete. This will all be an automated facility. I will take care of the automation on that. And that's what we got going on. This will be a blending where this stuff will be blended into the mixing hopper. Nice part about this facility is it'll be very easy to grow this facility a lot. We can fit grain cleaner in here, another bin, a dirty bin here to feed the grain cleaner. We can put 2 bins here, 1 bin here, extend this conveyor 10 foot and be more than double our ingredients. There's a lot of stuff we can do here that is won't take much infrastructure to double the size and capacity of the facility. So that's what we got going on. And if you want me to design a facility for you like this, just let me know. I do a couple of these a week and it's fun. So let's change a view here just to roll it around and look at it in a different view. But all the writing is in there that explains what everything is. I like when I design things, I like to keep things simple, like with having every auger that's 6-inch have the same RPMs, the same motor size. The reason, now you say, well, I'm going overkill on these 3 augers. Well, the reason is these augers are going to be running really slow. They're going to be running like 10 hertz. Could be, you could have one running 40, but you could have one of these running 10 hertz or even down as low as 5 hertz. So yeah, so 1 horsepower motor would run one of these, but if we're not going to have problems with what I'm going to be doing with this facility, these need to be overpowered. Now these over here, it's this 30 footer is spec'd at a 3 horse. This 24 footer 3 is plenty. But with doing it like that, it simplifies everything. It simplifies everything. Then there's no at building like we got the wrong gearbox on the wrong auger or something like that. Everything's just very straightforward on how everything's going to work.